Hello. So for this one, we're not doing a Pomodoro. I want for a project, I want a sparse array. So thought I'd make one in a playground. To start off with. So what is a sparse array? Well, an array is obviously I'm in the wrong language. I've been programming in C++ today, so I don't know what language I'm in. So a normal array is like this. And if we print that out, we get 0, 1, 2, 3, obviously, that's what we'd expect. And we can index into it. So array 1. And this is not sparse because is an array which has got length 4 and 4 elements in it. But if we want like a really big array that could be, say, infinitely large, that would take up all the memory, well, more than all the memory. But if we just wanted it to be sparsely populated, so most of the entries were like a default value, and only some had some value in, then we could store it in less space, and if we should be able to treat it just like any other array. So I'm going to build one of those. So sparse array. It takes an element. And the first thing we're going to do, so we're going to give it a dictionary, which is going to be how we look up the elements. So we just do dictionary in element. And we need a default. To return if we haven't got valid element. So that's kind of the structure. To be like an array, we need to implement a couple of protocols. First is to make it into a sequence. To make something into a sequence, it has to be sequence, and then if you make it an iterator protocol, you can quite easily add in the next, which gets you the next element. Now here, well, what do we return here? Well, it's a sequence, so if we start at element number 0, say, then we could return the element at that index. But if there isn't one, we just default the value. So that's how we do that. So this would never, but now we need to do something with so we're never going to return a nil, which is fine. But we need to increment the current index after we returned here. So there's a special keyword called defer where we can add plus equals 1 to the index. And we need to make this mutating. So let's try that out. So we've got a sparse array. Sparse array of ints. We should really make it construct with some elements and a default value in that order. Actually, we want to. Yeah, that's fine. Want to probably just give it an array. So init from an array. With a default value. That'll be our first implementation of the constructor. It's warm tonight. So we want array dot enumerated. Those are pairs. So we want we can use a dictionary unique key just with values. And set the default. So let's take and make a default value of 9. So we've got to map this to get rid of we want offset and element. Okay, so we should have sparse array constructed, and we should be able to do for each element. Now this, I'm not going to execute this because this will just go forever, because we never return nil from next, so this will essentially continue to count current index forever. So we need to actually give it a sub-array, subsequence, just to make sure that we actually don't hang. Oh, well, we haven't got any subscripts yet. Actually, let's do, yeah, because we haven't done the subscript. So we're just going to use the next of the sequence. So we can go through sequence. We know we're never going to get a nil, so what? Oh, I don't know what's going on. And there you go. We've got 0, 1, 2, 3, and then it goes 9, 9, 9, 9, 9, 9. And if we did it 100 times, we're just going to get the first ones that we actually set, and then a default value of 9. So that means that basically this array is as big as it can be. We can keep going next to the very end, but we'll never get to the end, and we'll return default values wherever there isn't one. The other thing this has is the next thing to do is to make it so we can actually subscript into it, and for that we need the collection protocol. And for a collection we need I think we need start index, and we need an end index. Now, because this is infinite, as close as we can get, have it like that, and then I think we need index after, and that's just going to be I plus 1. Must not contain stored properties. Okay, that's okay. So What am I missing? I think I might need to put in a subscript as well. Again, I'm going to get elements, position, or the default value, and here if we set a value, then that's all we need to do. I think that's collection. So now our array is also, we can also do index it. So 0 is 0, for a 100, say 1000, it's going to be 9, but we can now start setting, so we could set the element at 999 to be equal to, I don't know, and then we can have a look at it. So, and what we've got in A is we haven't got, obviously, stored all the numbers between all the things up to 1000. We haven't stored 1000 elements. We've just, let's get rid of this. We've actually only stored 5 key value pairs. So the original 4 plus the one at 999. So we can sparsely populate this array. It acts like an array. We can get a sequence. We can randomly access it. We can set it at any point up to, obviously, int max. And that's it, really. If we want to make it usable in SwiftUI, then there's couple more things we need to do to it. So all we need to do is extend it to make it bi-directional collection. Extend the sparse array. And for that we just add in index before, and the index before is obviously I minus 1. And then finally, if we then add the random access collection marker, we have something that can be used in a view in the for each. Because I think if we import for each, this data well, here's the right range, but we can have, if this basically subscribes to, we can just do that. Obviously I haven't got a view to put this in, but We just have to put in an ID of self for now. So that would give us, obviously, I don't think we really want to do that because we want to constrain this somehow. And if we put it into like a lazy h-stack, for instance, then a lazy h-stack will just get the entries it needs to do the display, so it won't like iterate through the entire array, which of course is essentially infinite. So we don't want to ever do that. We have to be careful that we're not doing that. Okay, well, that's a quick tutorial, I guess, for one of it, or swift play. Creating a sparse array, and basically you make it the same as an array by implementing the same protocols that an array would use. So this is kind of all the sort of protocol stuff that normal arrays implement, and that's why you can start using them as this sparse array just like it was an array.